Hello and welcome to Technical Utkranti, and today we'll be looking into the 7th question on linked lists. This is the thought for the day. Go through it and I hope it would be useful for you. So we have done these many questions on linked list and we are on to the 7th question, and let's get on understanding the question. We are given a Y-shaped linked list and we have to identify the common linked list, which is represented by the green node. The inputs given to us are the two starting points of the linked list, which is this node and this node. And from this we have to identify the common node of this Y-shaped linked list. So before understanding the solution given in this video, I suggest you to go and practice this question on LeetCode. The link is present in the description, and then come back and look at the solution. So let's see the first approach in solving this question. In first approach, we'll have a dictionary and we will iterate across one of the linked list and save all the nodes in the dictionary. So we'll have 1, 2, 5, 6, 7 saved as nodes, not as values, as nodes. This is important to remember. Then we'll iterate across the second linked list and we'll see every node if it exists, each node if it exists in the dictionary. So does 3 exist? It does not exist. Does 5 exist? Yes, it exists. So once you find the node which exists in the dictionary, you return that node as the answer. All right. In case if you have iterated completely on this linked list and reached none and you haven't find anything in the dictionary, then it means that there is no common node in this linked list, and as such this Y shape of the linked list does not exist. In second approach, what we'll do is, as you can see, these two linked lists are of different lengths. So what we'll do is, we'll calculate, let's say this is LL1 and this is LL2, and we calculate the length of these linked lists LL1 and LL2. So for LL1 it comes out to be 5 and for LL2 it comes out to be 4, right? So we'll find the difference of these two, which comes out to be 1, and whichever linked list is longer, the pointer of that linked list, we move this difference ahead. So we make LL1 go over here, which is one node ahead of its starting. And now you can see that both LL1 and LL2 are at the same distance from the common node, right? So here simply we will take both the pointers ahead one step at a time and compare if they are equal, and if they are equal, we've just got the common node. Okay, now let's understand the third and the final approach. So this is LL1, this is LL2, and in this approach what we will do is we will just iterate and keep iterating till one of the pointers reach the none over here. So as you can see that if both the pointers move one step at a time, LL2 will reach none and LL1 will come over here. As soon as the pointer of the smaller linked list reaches none, we make it point to the longer starting node of the longer linked list. All right. Then again, we will take one step ahead. So LL2 goes here and LL1 comes here. So as soon as LL1 comes here, it goes to the starting of the other linked list, which is LL1, right? So as soon as LL1 comes to the starting of this linked list, you can see that both LL1 and LL2 are at the same distance with the common node. Take one jump at a time and we'll find the common node. So I hope the three approaches were clear. Now let's jump to understanding the code. So before understanding the code, I'll just show you how I created the Y-shaped linked list, and then we'll understand the coding of three approaches. So linked list is the class, and I created three objects or three linked lists. So common linked list has the common part, and the two separate parts are LL and LL2. So I have inserted 1, 2 in LL and 3 in LL2. Then I had made the common part, which has 5, 6, 7, 8 elements. Then simply I have identified the last node of LL with this code, and the last node of LL is pointing to the first node of the common. In this way, I make LL as 1, 2, 5, 6, 7, 8. With the same approach, I make LL2 as 3, 5, 6, 7, 8. Alright. And then I run this particular method where LL is 1, 2, 5, 6, 7, 8. LL2 is 3, 5, 6, 7, 8. Right. So let's understand the first approach. So in first approach, I create one dictionary and the two pointers L1 and L2 pointing to the two starting nodes of the linked list. I'll just store all the nodes into the dictionary of one of the linked lists. Then I'll iterate on the second linked list, and if I found the node, I'll just indicate that I have found, and I'll return that particular node. Yes, we get 5. All right. Let's suppose we change this to 6. So I should get 6. Yeah. All right. Now let's understand the second approach. In second approach, I am simply finding the lengths, and if I see that length 1 is greater than length 2, then I'll move L1 len1 minus len2 steps ahead. Similarly, if I see that len2 is greater than len1, then I'll move L2 this many times ahead. So by moving ahead, I bring L1 and L2 at the same distance from the common node, right? And then I'll just see that until L1 lasts, I will compare both L1 and L2, and if they are equal, return L1. Otherwise, I'll just increment both the pointers L1 and L2 to their next nodes. Let's see if this works out. So I'll see, yes. And if I comment this out, yes. So this is working fine. And let's understand the third approach. In third approach, what we are doing, we are just iterating on both the linked list until one of the linked list reaches none, right? One of the pointer reaches none. So let's assume if L2 has reached none, then we'll make L2 point to the starting of the first linked list, right? Now, until L2 has reached none again, what we'll do is, okay, we'll just see that has L1 also reached none. In that case, we'll be pointing L1 to the starting node of the second linked list. Okay. Okay. Then we'll just compare both of the pointers, and then we will move L1 and L2 one step ahead. Similarly, if we'll see that from this particular hopping, if L1 has reached 1, so L1 was earlier pointing to the first linked list nodes. So if L1 has reached none, then it will point to the starting node of the second linked list, right? Then this particular code will go on until it has reached none while it was iterating on the second linked list. So this is used for hopping, this is used for comparing, and this is to check that L2, which over here which over here had not reached none. If with these iterations it has reached none, and point it to the starting of the first linked list. I hope if you have listened carefully and understood the approach illustrated on the board, you might have understood the code as well. Okay, let's see if this thing works. So yes, this is working. So I hope you like the illustration of approaches and the code. If you did like, please give it a thumbs up and keep me motivated to make such videos. Thank you. Bye bye.